this is a part of electricity. We know that electricity is used for different things. In this chapter you will see what are the effects of electricity in the form of chemicals. So electricity can bring out chemical changes, which is explained in this chapter. So let's start. And you know electricity we use every day in our daily life. It starts with, like, you all are familiar that you are told not to use an electric appliance with wet hands. It can give you an electric shock. So we should not touch. This is something which everyone is familiar. We have learned that the materials which allow electric current to pass, they are called good conductors. So which materials are good conductors of electricity? You know that metals are electrical good conductors. On the other hand, there are materials which do not allow electricity. You have done this earlier. And in class 6, if you remember, you did something about a tester which is shown here. In the coming class, I will be showing you how do you making of a simple tester and using the activities which are described in this chapter. I will explain how the tester is used for doing the activity. You will practically understand. A tester is made, and in this picture there is a tester shown here, and here it is showing that there is a bulb and there is a cell and there is a screwdriver. A tester is used to test whether a particular material allows the current to pass through it. So what is a tester? We find that metals such as copper and aluminium conduct electricity. Why is it copper and aluminium? You must have seen at home that the electric wires which you use at home, they are made from these two things. Copper wires. At home you have electric wires which inside they have got a brown wire, that is copper wire, and you have aluminium wires which are grayish in color. They are used and they are covered with rubber or plastic. So these are two things which we see every day. They are covered with plastic or rubber and wood. These are substances which we are familiar that they do not conduct electricity. Copper and aluminium, but plastic, wood and rubber do not conduct electricity. So till earlier classes you have done that. In this chapter you will read what about the liquids. In junior class, in previous classes you have read about solids. In this chapter you will read what about the liquids. Are they good conductors or not? So how will you test that a liquid is a good conductor of electricity? Again, there is a tester there. As I told you, I will show you. You can also make a tester. And there is a cell which is used to produce current. There is a bulb which will show you that when the bulb will light up, it will show that it is a good conductor. So how will you test? To test whether a liquid allows electric current, we can use the tester. The tester, the picture is given in the book. When you will use the tester, so what you have to do, there is a picture shown here. So this is the bulb, this is the symbol of battery, and the long line and the short line symbolize the battery. So longer line and shorter line is for one battery. This long line is for the second battery. This is the bulb and these are the wires. Here they have taken a liquid, and you can change the liquid and put the two wires inside the liquid. When you will put the two wires inside the liquid, if the bulb lights up, this means that the substance is a good conductor of electricity. And this is just explained in 14.1. So when I will show you a tester, I will show you practically that it happens. And you have to join this tester which is made actually this battery with the wire connected to a bulb, and the two ends are connected to substance. This is a solid. If you take the two wires and you join them together, if you take the two wires and you put the two wires together, what will happen? The current will flow from one wire and it will go into the other wire. So these two ends will conduct electricity and the bulb will light up. If you replace the two wires and you put them inside a liquid, then if the bulb lights up, then it means that it is a good conductor of electricity. Join the free end of the tester for a moment and the bulb will light up. First you are testing that the tester is having current or not. So what is being done here? That you have taken the two wires and you have joined together. If the bulb lights up, it means the battery is working. If the bulb does not light up, it means the battery is not working. And sometimes the tester may not light up, the bulb may not light up. So reason is given that the connections may be loose, or the bulb is fused, or the cells are not working. There can be three reasons. The connections may be loose, the bulb may be fused, or the cells are not working. And when all the connections are tight, replace the bulb with another bulb. Now test if the tester is working or not. If the tester is still not working, replace the cells. At home you have seen that the batteries which you use, they get used up when you use them more than once. So you have to replace the bulb and you have to replace the batteries. So if the batteries are new, then the tester will work, and when the activity is right here, you will take different liquids and the two wires are dipped inside the liquid. This is a lemon juice. You can remove this and then put water inside. You can put oil and different liquids. Now activity 14.2, collect plastic or rubber caps, pour 1 teaspoon of lemon juice vinegar in one cap and put the two wires inside the liquid. And they have taken lemon juice, vinegar. You can test it with the use of lemon juice. You can put this liquid can be a lemon juice, it can be water, it can be distilled water, it can be milk, any liquid. Now if you put the two wires inside it and the bulb lights up, which means this liquid is a good conductor of electricity. If the bulb does not light up, it means the current is not traveling from this wire to this wire. The circuit should be complete. How does the bulb light up? If the two wires are joined together. So if the two wires are not joined together, we are trying to join them by putting them inside the liquid. When you put them inside the liquid, the current will flow through the liquid and to the other bulb, and the bulb lights up. So this is used for testing that the liquid is a good conductor. When the liquid between the two ends of the tester allows the electric current to pass, then the circuit of the tester becomes complete. When the circuit is complete, the current flows and the bulb lights up. This shows that the liquid is a good conductor of electricity. When the liquid does not allow electric current to pass, then the circuit is not complete and the bulb does not glow. So a few things can happen. Either the bulb will glow or the bulb will not glow. When the bulb lights up, this means that it is a conductor. The liquid was a good conductor. In some situations, even though the liquid is a good conductor, the bulb may not light up. Why will the bulb not light up? If the liquid is a good conductor, it could be any reason. It could be that the bulb is not functioning, it could be wires are loose, or any reason. But if everything is correct, then the bulb will light up. And do you remember why the bulb glows when the current passes through it? The bulb glows because the current is passing through it. And how does the bulb light up? Due to the heating effect. This is another effect of current. In this chapter you are reading about chemical effect of current. The filament of the bulb gets heated and it starts glowing. So when the filament of the bulb gets heated to a high temperature, in this bulb, when the current is passing, there is a filament. Inside a bulb you must have seen there is a filament, there is a coil. So when the current current passes through this wire inside the bulb, this wire which is inside the bulb becomes hot within very short time, within fraction of a second, and it becomes so hot that it starts giving out light. When it gives out light, that is described here. This is called incandescence. You can write that word. It is called incandescence. What is incandescence? It is the property by which a substance incandescence. So it is the property of a substance to give out light when it becomes hot. So when the current passes through the wire, then the bulb gives out light. That is called incandescence. So this is the reason why the bulb. So this is another effect of current which is described. If the current through the circuit is weak, then the filament will not get heated. So normally nowadays you will get bulbs which are of very low voltage. Low voltage means basically LED bulbs. Earlier the bulbs were not LED bulbs. They needed high voltage. But here they can use a normal LED bulb, and the bulb needed high voltage. So then only it would give out light. Then why is the current in the circuit weak? The current in the circuit could be weak due to various reasons. One of the reasons will be that the bulb has become weak. The bulb has lost its voltage. The material may conduct electricity, it may not conduct. As a result, the circuit of the tester may be complete. So the circuit may be complete and the current through it may be too weak to make the bulb glow. These are some conditions. If the circuit may be complete, yet the current is not flowing. So if the current is weak, which can happen due to the weakness of the cell, then the bulb will not glow, and then we have to replace the bulb. We can use another effect of electric current to make another kind of tester. So what is a tester? A tester is a simple device which is used to test the current flowing through a circuit. The electric current produces a magnetic effect. Now this is another effect of electric current, that electricity when it passes through a substance, it can change its chemical property. When it passes through wire, it can produce a magnetic effect, magnetic field around it, that is called magnetic field. What happens to a compass needle is kept nearby when the current flows in a wire. When the current is flowing in a wire, then it produces a magnetic field. Now this will be clearly understood when I show it to you with an activity where I will show you that the tester is actually made and it actually does what is described here. So here there is a magnetic compass and there is electric wire and the same circuit with current flowing through it. So when the current is flowing through the wire, it is seen that the wire produces a deflection in the magnetic compass. When the current passes near the magnetic compass, it produces a magnetic field. So that magnetic field is making change in the magnetic compass, and therefore the magnetic compass needle also gets deflected. Even if the current is small, the deflection of the magnetic needle can be seen. So this tester is also another kind in which you are using a magnetic compass, in which you are not using a bulb, in which you are using a magnetic compass to test. So if the magnetic compass shows deflection in the needle, if the needle moves, it means the current is. If the magnetic needle does not get deflected, this means that there is no current in the circuit. What does this tell you? A very important point about electricity. The important point is that whenever any electric current flows through a wire, the wire produces a magnetic field. It produces a radiation in the wire. So around the wire there is a field produced. So do you think there is a magnetic field used around? So if you have a magnetic compass at home, you can try that out. Take the magnetic compass near a television, take it near electric wire, take it near any device where electricity is flowing, and you will see that the magnetic compass actually gets deflected. Why does this happen? Because the magnetic compass itself is having a field and the electric wire is itself having a field. So both the magnetic fields of the wire and the compass get deflected, and it shows reflection in the magnetic compass. So this I will show you with an activity where this thing which is described here you will see, and in the meantime you can see it at home also if you have a magnetic compass and see actually it has happened. And there are things, something you must have seen at home also. These are bulbs which you will see inside a remote, inside a mobile. These are bulbs which you will see in lights which are used everywhere. There are LED lights. So these are lights which have bulbs in which there is a long wire and a short wire. It is called LED. LED glows when the current is. What is and why is LED bulb famous now? Because it is a bulb which works with. What is the meaning of LED? Light emitting diode. L is light, emitting is emitting signal, and diode is diode. It has got diode. So it is light emitting diode in which there are two wires which are called this attached to the LED. Now you must have seen this. There are two wires, and this bulb you can see inside a remote, on a television. You will see everywhere now. All the devices, LED bulbs are used wherever there is electricity. There is no big bulb used now. So these are used for indicating light, and these LED bulbs are having two wires, one long and one short. It is written here, one line is longer than the other. While connecting to the circuit, the longer lead is always connected to positive. So if you see that this is long, this should be connected to plus, and the short one should be connected to negative. So the longer lead is connected to the positive wire, which is long will be connected to plus. Now what is this plus? If you see the battery, there is a plus and minus shown. So all this and this bulb and the working of the electric bulb and the working of the diode and the tester I will show you in the practical activity. And this shows that these are the LEDs which are used in the experiment. So this experiment of this also I will show you in the next class. So till where we have done